73. Is that correct?
Mm-hmm.
24.
Oh my God.
Okay. Okay. There is a really cool dialect of math called linear algebra. And linear algebra deals with finding the solutions to linear equations. And in many dimensions, not just 2 or 3, but in many, many, many dimensions. That's the cool thing about math. You can have more than 3 dimensions. That's what allowed Einstein to go for the 4th dimension, which is time, right? Because just in the physical world, apparently you only have 3 dimensions, but in reality, you can also add the 4th dimension. Past the 4th dimension, I don't know. I think you've got to take something extra to get to the 5th or the 6th dimension, but that's another issue. We're not going to go there right now. Okay, so Cramer's rule is applying linear algebra to solve for x and y. And if you have this, and we did it in a previous lesson, so it shouldn't look so weird. Remember when we multiplied this one times minus c and this one times a, and we got all the ones, I don't remember what lesson that was, but we did it. And there's an easier way of looking at it. If you take something called a determinant, or if we put it in a matrix. Did we see matrices already? We did. So I'm going to put it in a matrix, okay? And I'm going to have do you remember when we saw the determinants?
Mm-hmm.
I'm going to have the determinant of this one, and the determinant is going to be A, B, C, and D, correct? But if I want to find x, and I think I mentioned that day, you take E and F, and you put it, if this is a line and you only have x's, and you put it, instead of the A and the C, I would have E, F, B, D, right?
Mm-hmm.
And that will give me x. How do you think I would do y? And I'm going to finish this thought in a second.
The same thing, but instead of AC would be BD.
Very good. I would have AC, and I would have EF here. Okay? And you remember that the determinants are found doing this. First here, and then up here. Remember? So you would have, in the bottom, we would have AD minus CB. That's in the bottom. And in the top, same exact thing.
ED minus FB.
FB first. I know, ED, you're right. ED minus FB. Easy, right?
Mm-hmm.
This one here would be AF minus CE over, same thing, AD, CB. And this is guess what the guy's last name was?
Kramer.
Got it. Okay? Really easy, right?
Mm-hmm.
That's it.
That's it. What if this happens to be 0?
Which one?
The bottom part.
You
If the determinant is undefined,
you put 1.
you put 0. I mean, you put undefined. If this one in the bottom is 0, then this can't be solved. It's probably parallel lines or the same line one on top of the other. Okay? Because you do understand that this is a system of lines, right? This represents one line and this represents another line. And you're trying to find that intersection. If there isn't any intersection because it's parallel, or if it's the same line one on top of the other, it's going to be undefined because how do you find it? Right? There's no intersection. Okay? Are we good? Do you need more? Or pretty easy, right? Just following the formula?